Good morning, afternoon, evening, everyone, wherever you are in your location. So we have this Gen AI series for AWS. Many presentation in this series. We already have a playlist. If you are interested in this, please go through the playlist and based on your interest level, you can. There's multiple videos for Gen AI application. You can um, attend based on your what is a specific area of your interest. So this is one of the in that series. This is focus on the Gen AI solution demonstrate how to leverage Amazon SageMaker and Amazon OpenSearch uh, to implement a retrieval augmented generation RAG application that make personal book recommendation through a generative AI large language model and a vector database. So, in this overall architecture of the solution, we showcase the powerful combination of Amazon SageMaker and Amazon's Open Search in creating a personalized book recommendation application. By utilizing a retrieval augmented generation RAG approach, we leverage a generative AI large language model and a vector database to provide tailored book recommendation to the users. This innovation solution demonstrates how to enhance the capabilities of LLM by incorporating relevant context and information from a vector database, resulting in more accurate and personalized recommendation. So let's look at the enhancing LLM capability with a vector database. So in this solution, we demonstrate how to enhance the capabilities of a large language model LLM by incorporating a vector database and semantic search. By leveraging these technologies, LLM can become more predictable and accurate in their um, response as they can access relevant knowledge based on the user's input. This approach leads to more personalized and informative interaction, improving the overall user experience. Large language models or LLM can be enhanced and made more reliable by integrating a semantic search. This process helps the model retrieve relevant knowledge from the user input before generating a response, resulting in more accurate and predictable outputs. Enhancing search with semantic what that's what it's focusing in this slide. So unlike traditional search method that simplify much keywords, semantic search takes the step further. It focuses on understanding the intent behind the user's query and the contextual meaning of the word. This allows for more accurate and relevant search results that align with what the user is actually looking for. Okay, so this step focus on creating a knowledge base for their RAG applications. So this is an initial step involved building a comprehensive knowledge base that is tailored to the specific requirement of the RAG application. The knowledge base serves as the foundation for the system, providing the LLM with the necessary information and context to generate accurate and relevant responses. The content of the knowledge base should be carefully curated with the organized to ensure its effectiveness in supporting the application goals. In this step, we'll focus on building the knowledge base of the RAG application. This step highlights the importance of creating the comprehensive knowledge base uh, tailored towards the specific application. In this case, since the application focus on the book recommendation, the knowledge base consists of a large corpus of the raw books data. This data include essential information such as the author, title, plot summary, and generate, providing the LLM with the necessary context to generate accurate and relevant recommendations. This step is for preparing the data for the semantic search with the SageMaker. So Amazon SageMaker Studio and Jupyter Notebooks are essential tool for data engineers. They allow for the analysis and the preparation of the raw data, converting it into a format suitable for semantic search, enabling more efficient and relevant data retrieval. So let's look at how the conversion of the knowledge base into a vector database. This step highlights the process of converting the knowledge base into a vector format. Data engineers deploy an embedding machine learning model such as Bloom 7P to a SageMaker endpoint. This model is responsible for transforming the textual data of the knowledge base to a numerical representation known as the vector. The vector representation captures the semantic meaning and the relationship between different concepts within the knowledge base, enabling the LLM to effectively retrieve and process relevant information. So just understand the embedding vectors. So this highlights the concept of an embedding vector. An embedding vector is a numerical representation that captures the semantic and systematic relationship between the word in the knowledge base. The representation allows the LLM to understand the meaning and context of the information, enabling it to provide more accurate and relevant response. This step highlights the importance of storing the generated embedded vector for future reference. The vector, along with its corresponding textual equivalent, can be stored in a database like Amazon Open Search service. This allows for efficient retrieval and utilization of the vector data, enabling the LLM to access relevant information and generate accurate response. So in this slide, we'll focus on the highlights of the role of open source service within the solution. As a capable, flexible, and extensible open source software suite, open source service provide a powerful platform for search and analytics application. By leveraging open source service, the solution ensures the efficient storage, retrieval, and analysis of the embedding vectors, enabling the LLM to effectively access and utilize the relevant information. This robust and adaptable platform contribute to the overall performance and accuracy of the book recommendation system. In this step, we highlighting the versatility and the power of open source service. The vector database capable of open source service enable data engineers to implement a wide range of application, including semantic search, retrieval augmented generation RAG with LLMs, recommendation engines, and search-rich media. This demonstrates the broad applicability of open source service various domain and its potential to drive innovation and enhance data-driven decision making. This step highlights the implementation of the inference-based LLM. Once a vector database is populated with the embedding vectors, data engineers can deploy an LLM such as the Falcon 7P model to interact with the database and generate recommendations. The LLM will leverage the vector representation to retrieve relevant information from the knowledge base and provide accurate and personalized responses to user queries. This demonstrates the power of combining LLM with vector database to create an intelligent and effective application. In this step, the highlights to it's a core functionality of the application. User questions are converted into their vector representation, allowing for efficient comparison and retrieval of the relevant information from the vector database. By conducting a semantics search against the open source service vector database, the system can identify the most relevant record based on the semantic similarity between the user's query and the store vectors. They enables the LLM to provide an accurate and personalized recommendation, effectively addressing the user's need. This step highlights the importance of prompt engineering in optimizing the LLM's response. The retrieved record from the vector database can be used to refine the prompt, ensuring that it means the sentiment and the context of the original question. The refined prompt guides the LLM to generate a response that is not only relevant but also aligned with the user's intent and expectation, creating a more human-like and engaging interactions. In this step, we are highlighting the importance of maintaining the accuracy and quality of the knowledge base by continuously updating and cleaning the raw data using utilizing the pandas replays organization can ensure the LLM has access to up-to-date data and reliable information. This contribution to the accuracy and relevancy of the generated recommendation, improving the overall effectiveness of the application. Let's look up the solution. What what is the solution is, and also the component of the solution. So we showcase the powerful combination of Amazon SageMaker and Amazon Open Search in creating a personalized book recommendation application. By utilizing a retrieval augmented generation RAG approach, we leverage a generative AI large language model and a vector database to provide tailored book recommendation to users. This innovative solution demonstrates how to enhance the capabilities of LLM by incorporating relevant context and information from a vector database, resulting in more accurate and personalized recommendation. So, so let's list the key component and their role. Amazon S3 store the raw book data. Jupyter Notebook used for data exploration and experimentation. SageMaker Studio, a web-based IDE for machine learning development. Falcon 7 for inference. This is a model for the LLM for generating recommendation. Open Search Service, vector database store embedding of book. Um, RAG, the Retrieval Augmented Generation Framework. Bloom 7p embedding uh, model used to create embedding of book data. Data engineer, the role responsible for preparing and managing the data. Users, the end user who receive a personalized book recommendation. Thanks for attending this session. Hope you got good understanding of how to create a rack-based solution with Amazon Open Search and with SageMaker and embedded database. Thank you.